All right, let's talk about cloud network security. Specifically, we're going to get into who gets in, who stays out, and why that first line of defense you've set up, well, it might just have a blind spot you need to know about.
So, let me just ask you this straight up. If your cloud environment were some exclusive VIP club, are you 100% sure your guest list is totally foolproof? That's really the core question we're digging into, because in the cloud, it only takes one uninvited guest to cause a whole lot of problems.
I want you to think of your network security group as a kind of digital doorman. Its whole job is to stand at the front door of your cloud environment and make sure no shady traffic gets in. Only the legitimate, expected guests are getting past the velvet rope.
And what's the first tool this doorman uses? A list. A really, really carefully kept list. It's basically a set of rules to check every single packet, every piece of traffic that tries to get in. It sounds fundamental, and it is, but as we're about to see, the devil is really in the details.
So, this brings us to the old school way of doing things, the Access Control List, or ACL. This is basically the doorman's clipboard, the detailed instruction manual for who gets a nod and who gets turned away at the door.
So what is an ACL? Well, it's pretty much what it sounds like. It's a list of rules that looks for a pattern. If the traffic coming in matches a permit rule, hey, come on in. If it doesn't, you're denied. It's a simple idea, but it's incredibly powerful in practice.
Now here's where it gets interesting. That check is super specific. It's called the 5-tuple. Your digital doorman isn't just glancing at where the traffic is coming from, the source IP. No, it's checking the protocol, the exact port it came from, where it's trying to go, and which port it's aiming for. It's like a 5-point identity check for every single connection that shows up.
Okay, but can you imagine trying to manage those IP lists by hand? It would be a complete nightmare. It's like asking the doorman to memorize the face of every single approved guest, a list that changes every single day. That's exactly why Azure came up with a brilliant solution, service tags.
And this chart just lays it out perfectly. The old way, you're constantly updating lists, double-checking for typos, and just worrying all the time. But with service tags, Azure manages the entire VIP list of IP addresses for you. It is always accurate, it's always up to date, and it just takes a massive weight off your shoulders.
And just so you know, this isn't some brand new experimental feature. Azure rolled this out way back in 2018 to solve this exact headache. It lets you create these simple, easy-to-read rules like, hey, allow all traffic from Azure storage, and you never have to know or manage a single one of the IP addresses behind it.
Okay, so we've got an automated, always accurate VIP list. We should be totally safe, right? Well, this is where our story takes a little bit of a dark turn. What happens if someone shows up with a perfect forgery of a VIP invitation?
And here it is. This is the crucial flaw in our logic. Just because an IP address is on the allow list doesn't automatically mean that the traffic itself is safe. As the slide says, a known address can be faked.
This little trick is called IP spoofing. A hacker basically just slaps a trusted source IP address onto their malicious traffic. So to our digital doorman, it looks like a legitimate guest because the invitation, the IP address, it looks completely real. And just like that, they can waltz right past our first layer of security.
Now, to be fair, Azure has some really strong defenses against this stuff. It uses built-in DDoS protection to fight off big attacks, and a system called RPKI to help verify that traffic is coming from where it says it is. But all of that works at the network level. A really clever attacker can still find a way in higher up the chain, inside your application itself.
So this pushes us toward a much smarter, more modern security philosophy, and it's absolutely essential today. Trust but verify. We can trust that the IP is probably from the right location, but we still have to verify that it's from the right person. This is the big takeaway here. An IP address is like the return address on an envelope. It tells you where the letter was sent from, but it doesn't prove who actually wrote it. And relying only on that return address, well, it's just not enough.
And here is a really critical question you've got to ask yourself. When you use a service tag, let's say for a big service that lots of people use, you might be allowing traffic not just from your stuff on that service, but from other customers of that exact same service. Really understanding what each tag allows is key to knowing your real risk.
So the solution here isn't to just throw out service tags. They are an amazing first line of defense. The real solution is to build more layers. A truly strong defense is never just one tall wall. It's a whole series of checks and balances.
So what does that look like? You have to give your doorman more tools. First, strong authentication to prove who the user is, not just where they're coming from. Then, you validate the data inside the application, like checking for special HTTP headers. And you can use incredibly powerful tools like Private Link, which basically creates a secure private tunnel to services, so you're not even touching the public internet. Every single one of these is another crucial layer of your security onion.
So we kind of end up where we started, but with a whole new perspective. Azure Service Tags, they're a fantastic doorman for your cloud, but that doorman should never, ever be working alone. Your guest list is a great start, but real security comes from asking, okay, what's my next level of verification?